Hello, and welcome to GSA's Cloud Mini Series. My name is Ernest Rosser, and I'll be your host for the Cloud Architecture Design and Engineering session. I serve as a Cloud SME in GSA's Federal Acquisition Service, Information Technology category, IT Products, Cloud and Solutions Development branch. I'm part of a team that is responsible for cloud software category management that assists federal, state, local, tribal territories, and other eligible agencies in navigating and procuring cloud services through contract vehicles. I'll be presenting on one of more to come Cloud Mini-Series offerings, so please feel free to look up our other videos brought to you by our team of Cloud SMEs. So let's move forward into the presentation. As I mentioned earlier, I'll be discussing cloud architecture, design, and engineering principles, but to be specific, it will be approached from a high level, so not to get into the weeds of specific cloud service providers or software services. The agenda. The agenda will consist of discussions involving cloud architecture design, core services, and identity management, role-based access, networking, configuration management and change control, and lastly, DevSecOps. The discussion will be centered from a point of view of a cloud administrator with root access to core cloud service offerings, budget oversight, and a wealth of knowledge from numerous successful cloud migrations from on-prem to the cloud or across cloud from CSP to CSP. My background consists of extensive cloud practitioner operations, on-prem to cloud planning and migration, infrastructure architecture support, and planning, as well as data center style server and application process administration. I've touched on all aspects of cloud security to include getting authority to test, getting authority to operate, and the yearly audits that come from that ATO to remain in compliance. Operations program management, as well as budget. You have to know how to manage the cloud budget because it's easy to get out of hand very quick. We all know that one administrator who is driven to get things done and ask for approval later. That can prove costly in the cloud. This slide is a bit of a challenge, purely because of the scope and the many directions it can take. And it's the first one. How can I cover this to make good points to pique the thought process? Let me start by saying the bullet points are just highlights to get you thinking. More importantly, upfront work needs to be done on understanding the agency need, your IT culture needs, because training may be required, a specific focus on your outcomes of what you want to achieve, and to start off small, just to name a few. Private, hybrid, and multi-cloud. Private cloud is used by single organizations comprising of multiple consumers, for example, business units. It's owned, managed, and operated by the organization, whether it's on or off premises. Hybrid cloud is a composition of two or more distinct cloud infrastructures, whether private or public, that remains as unique entities, but are bound together by standardized technology that enables data portability. Multi-cloud is not a specific CSP design, but it allows multiple CSPs into one cloud offering for an agency. It could fit into either a private or hybrid cloud because it offers CSP-specific offerings that may benefit each agency better. But it comes with some drawbacks. The network has to be able to support it by design and efficiency. Of course, IP address management in the cloud is very unique, mainly because of the cloud's use of IP address space. We'll talk more on that in the upcoming networking slide. The point here is to ensure you have enough IPs to cover your well thought out design, specifically identifying enough IPs for each subnet and or VNet across on-prem and the cloud. This may not be a huge issue due to the OMB IPv6 transition mandate, but it's best to plan ahead and accommodate while building a new environment. DHCP and static IP is self-explanatory. Just know that you may be better off using one or the other based on your design. Whether VM hosts using static IPs, cloud-based desktops using DHCP, or some platform as a service and software as a service offerings may benefit more from using DHCP. Network routing for efficient data movement. This can be a big one because your employees or your customers need to have efficient network routing. Pay attention to region-specific routing and cross-region routing for external connections as well as possible DR site deployments. This also comes into play for hybrid type deployments where you are connecting to on-prem locations. Look into researching advancements made from the TIC 3.0 that may remedy this for you, or at a minimum give you more ideas on deployment options. One of the great things about cloud is region-specific deployments, which can aid in disaster recovery or failover sites. If you have a disaster recovery need, this could answer the bill. I suggest using a DR region that offers identical capabilities as your home region to make the seamless failover design easier. You will also learn that specific regions may not have the exact same offerings, and also the cost of some services may be different. This needs to be understood and accounted for as it impacts costs. Identity management approach, or specifically cloud identity access management. A brief definition. It is a security framework deployed in the cloud used to verify users and control their access rights to include issuing and denying access privileges. Cloud identity access management also enables you to grant access using a higher level of specificity of cloud resources to an individual or project level access. Separation of privilege refers to the principle that no users should be given enough privileges to misuse the system on their own. This is not the same as separation of duties, which requires the splitting of tasks among employees to reduce the chance of one employee committing a security violation or causing harm to the agency. Separation of privilege can be implemented in a number of ways. Some of those are separating various administrative account functions from each other, separating administrative and standard account capabilities, and separating auditing and logging capabilities within each user account. You can find more information on identity management from the website idmanagement.gov, and then scroll to the bottom of the page for playbooks. Security Assertion Markup Language, SAML 2.0. SAML 2.0 is an open standard cross-cloud identity provider that many identity providers use. SAML 2.0 allows for federated access to allow a user or application access to multiple web-based APIs that are used by the agency while using one set of login credentials, hence SAML single sign-on. It was created to simplify the authentication process where a single user needed to access multiple independent web applications across multiple domains, taking away the need for multiple user accounts and passwords, and ultimately reducing the help desk trouble ticket requirements of password resets. As you can see, SAML 2.0 opens the door to cloud resources and also remedies some antiquated designs for access. While SAML is an identity provider, you should also have a service provider to manage the need to control and update user identities and accounts for specific access to the environment. These user identities should be managed using the best options to accommodate your operating system, keeping in mind that it needs to be compatible across the CSP environment. Role-based access or role-based access control is a security approach that authorizes and restricts system access to users based on their roles within the organization. This also allows access to systems, the data, and applications needed to fulfill their job requirements and minimizes the risk of unauthorized employees accessing sensitive information or performing an unauthorized task. Master tenant ownership. Master tenant ownership can be viewed as the highest level access to your cloud service provider account. You have to have master control of your cloud infrastructure as well as having tenant ownership of your specific cloud infrastructure resources. A CSP supporting a single agency through multiple tenants can observe issues with cross-tenant administration if you not have a common tenant owner. Tasks such as tenant migration of servers could prove problematic. One agency could have multiple tenants that spans across private, public, and hybrid cloud offerings, and each tenant would have its own billing and portal administration environment. Permissions delegation model, portal administration, platform, virtual machine administration. A typical permissions delegation model is used to ensure a successful delegation of access. It is important to adhere to the principle of least privilege, which ensures that users and service accounts are only allowed to perform tasks necessary for their roles. Essentially, administrators should only use their administration account when admin duties are required and use their user account for normal daily functions, not requiring elevated privileges. Portal administration. Portal administrators will have varying levels of administrative rights. You have a master account owner, which allows you to assign lower level access to different users, whether it's database admins, file system admins, server admins, and application platform admins, just to name a few. A correct portal administrator account will also allow you to assign other agency portal administrators access to your specific portal instance if you need them to manage specific tasks in your cloud environment. Virtual machine administration is pretty much straightforward. A virtual machine administrator has access to administer, deploy, build, destroy, shut down, and restart virtual machines in the cloud virtual environment. The virtual machine administrator typically will not have access to the networking section or the networking profiles for the cloud environment. This follows the previous discussion of privilege separation based on roles. RBAC and separation of duties go hand in hand. This brings us to networking. I mentioned earlier that IPs are a valuable resource to the cloud purely because of how cloud service providers use the IP space. You're going to have to ensure that you have enough IPs for each machine or application, along with the virtual network switches, virtual firewalls, and virtual routing environment. These requirements are not new for network designs, but it could be new if you are not aware that a CSP uses multiple IPs per subnet or virtual network for their internal design that are not able to be used by the agency. You also need to understand your network configuration, whether it consists of a single region deployment or multi-region deployment. This should drive you to use all routable IPs and could prove problematic if relying on non-routable IP space. Say, for instance, you are deploying failover sites or a cross-region design. You wish to have server A, which is in region A, connect and communicate with server B, which is in region B, or server C, which is in region C. More than likely, you will need to have routable IPs, which will allow you to quickly deploy a failover site with near instant recovery. It all depends on your design and agency need. Technical hurdles of IPv6. IPv6 works. It answers the call. It gives us all the IPs we need, but as an administrator who in their past life who did not run full speed ahead to deploy, I offer some cautionary remarks. It goes back to my previous statement early on about knowing your IT culture. More than likely, you have an administrator who can quickly rattle off a server subnet just by stating 192.168, or a database admin who connects to a server by IP instead of a host name, or a network administrator who is not using the long IPv6 IP address. You also need to ensure that your applications support IPv6. Most do, but some of us are probably still using some older applications that do not. Yes, we were supposed to be on IPv6 already, but more than likely my previous hurdle topics has played a part in the delay. Please take note of OMB mandate M2107, which does direct transition to IPv6. Zero Trust Network. Zero Trust Architecture. Zero Trust Network does a lot to secure and future-proof our networks. So what is a Zero Trust Network? A Zero Trust Network does pretty much what the name implies. It trusts no one. It removes the implicit trust rule that's seen on traditional networks. It prevents full access to network resources once you have access to the internal network. This is very important since most everything in today's cloud environment are systems distributed among on-premises and cloud service providers. And adding on to that, remote workers needing access to agency data. This creates a hurdle for traditional network perimeter controls. So in walks Zero Trust Network security model, where no one is trusted. Every step you take to gain access to a resource or environment, Zero Trust Network checks to see if you belong there by verifying your location, type of action being done, timestamps, and do you have approval to access such resources. This clearly minimizes the impact of a security breach. This is a continuous process, unlike the one security check, and access is granted to the entire network of the traditional network model. There's also a solution called Zero Trust Network Access. It removes the need for a traditional agency VPN deployment, but follows the Zero Trust Network principles, verifying each and every step you take to access a specific resource using clearly defined access control policies. There's no agency VPNs to update or patch, and no VPN help desk trouble tickets to support. That's a win-win in my book. Zero Trust architecture identifies a thought process in order to deploy a Zero Trust network. For a brief GSA description, you can see the picture to the right. GSA uses 8 pillars of Zero Trust architect. The DoD uses 7, and CISA uses the core standard of 5 that's represented in all the others. This represents agency unique implementation, but following the core specifics. Network peering with on-premise networks. This is more or less a hybrid type of cloud deployment where you are focusing cloud servers or services to connect to identity and service providers on-prem to join the domain, or on-prem servers pushing data for application database, or even website updates to cloud servers. This also goes back to my earlier comment about efficient routing connections. Egress. Egress also needs to be discussed and tied into efficient routing. You do not want an East Coast connection egressing to the internet on the West Coast or vice versa. You also don't want your egress connections to be from the cloud through an on-prem network or router. Let's follow the rules of TIP 3.0. Configuration management and change control. Configuration management and change control is critical to your agency's security posture and also its operating budget. Configuration and change management processes must incorporate industry best practice, which support optimal production systems availability and effective system management. To have an effective configuration management and change control process, you have to have clearly identified roles and responsibilities of specific personnel or positions within your agency. Those individuals or positions have to be comfortable with the approving and issuing of policies, procedures, and guidance for implementing an effective change control process. You should also have a change advisory board, or CAB, which will be responsible for enterprise risk management, communication management, budget ramifications, and process compliance review of approved changes, and to ensure the change outcomes are communicated to the executive leadership. A CAB should be comprised of a snapshot of your current IT department, so all parties are presented and have an opportunity to weigh in on a proposed change. Changes should be documented and tested to iron out possible impacts or to verify rollback strategies are viable and reduces downtime. Change control impacts all of the below items identified in this presentation. You need to understand your configuration management process to support your cloud fabric structure, which is your entire networking architecture for infrastructure as a service, your platform as a service, or your access into the software as a service environment. You need to have a change management process around portal access to accommodate personnel adds or deletions, network storage configuration access, such as file level access or administrative access, and root access for Linux-based systems. That's a major one because root gives you complete access to the entire system. VMs will need a change process to incorporate patch updates, when to push patches, when to reboot systems, and also rollback plans and the understanding of possible downtime involved. You don't want VMs rebooting during the busiest time of the day or when your users are accessing them. Of course, in today's day and age, you're going to have to account for mobile devices like iOS and Android-based endpoints as well. Each will have its own set of rules and requirements for change control and configuration management, above and beyond the classic Windows or Linux-based systems. DevSecOps. What is DevSecOps? It's short for Development, Security, and Operations. It's an extension of DevOps that incorporates security into every step of the software development lifecycle. It can be visualized in the picture to the right as a frame of reference. Though not specifically identified, you can see where security can be integrated into each step, therefore hardening the software development lifecycle practice. Some major benefits of using DevSecOps is increased software security, increased collaboration between security teams and development teams, faster software code delivery, and establishing a repeatable process. This tends to show the rewards of a cheaper price tag for software development, but also increasing the security. Who would not want that in their workflow? Provisioning tools. Agencies can deploy a number of tools to help minimize risk in software development pipelines to increase output and increase security awareness. One tool that comes to mind is a vulnerability scanner. They can automatically scan software at various stages to look for known vulnerabilities and report. Configuration enforcement tools. They will push a specific configuration and then validate or identify a remediation action if not applied. You should also look into code repositories. A code repository should consist of archived code that is being worked on along with documentation or notes for actions taken on the code itself. It should be used for collaboration as well and is often housed in the cloud for ease of collaboration access. Packet Manager. Packet Manager is a system or set of tools used to automate installing, upgrading, and configuring software. Ideally, developers use a package manager to discover and install developer tools. Security tooling and operation. Security tooling uses software tools to identify vulnerabilities and risk identifications. Tools such as security information and event management solutions allow continuous monitoring and logging. Coupling that with an automated process of a notification could be the deciding factor between an open or prevented security breach. In closing, I would like to thank you for taking the time out of your day to review the GSA Cloud mini-series that presents cloud architecture, design, and engineering in a vendor-neutral setting. I also must say that it was presented from an in-the-cloud level view. Yes, pun intended. This prevented me from going into specific details on all topics because it was designed to offer suggestions to start your thought process. But I would like to offer that we are here to assist with those vendor-neutral in-the-weeds questions. So please reach out to us at cloudinfo@gsa.gov. Thank you.